Hi, in this video, I'll explain the difference between an observational study and experiment and show you how to distinguish between them. But first, to understand the difference between an experiment and observational study, you must understand the concepts of variable, explanatory variable, and response variable. So let me talk about that first. A variable is an attribute or characteristic being studied that can be measured or observed and that can assume different values. In other words, it's the value that you are measuring or observing in your research. For example, we want to study the length and width of cars. Maybe we want to design parking spaces or car garages. Well, the cars or the objects we're studying, we call them the population of interest. The word population of interest is a technical term. Now, what attribute or characteristic of these cars are we observing or measuring? Their length and width. That means there are two variables here, the length of cars and the width of cars. Those are the variables. Next example. We study the educational levels of people in Minnesota by county. Well, what is the population of interest? Meaning, what are the people, animals, or things that we're studying? It's the people of Minnesota, right? We're studying them. What are the variables? What are their attributes or characteristics that we're observing or measuring? Hit pause and think about it before I move on. Well, one variable is right in the statement of the question itself. It says we study the educational levels, so the educational levels is a variable. But look, we're studying the educational level by county. That means we're also observing and measuring, meaning writing down the county that the people are in. That's the second variable. There are two variables here, and they are educational level and county. Let's now talk about the concepts of explanatory variables and response variables. When a study has several variables, sometimes some of the variables feel like they are the input, like an x variable in algebra, and the other variables feel like some output, like a y function or y variable in algebra. If a variable feels like an input variable, we call it the independent variable or the explanatory variable, like an x in algebra. If a variable feels like an output variable, we call it the dependent variable or the response variable, like y in algebra. So the x variable is called the explanatory and the y variable is called the response. Well, the word explanatory sounds like an X, and that's how I remember which is which. Let's look at example 3. We want to study what happens to the blood cholesterol as teenagers grow older. What's the population of interest? The teenagers are the people we're studying. They are the population of interest. The values that we're measuring, observing of these teenagers are the blood cholesterol, but also their ages. Thus, blood cholesterol and ages are the variables. Is there an input-output kind of situation in this study? By the way, in reading these problems, it's a pretty good idea to try and imagine what are the researchers trying to achieve. That helps a lot. So press pause and try to think about what the researchers are trying to achieve and whether there is an input-output situation in this study. The answer is yes, there is. It feels like the researchers are trying to see if different ages correspond to different cholesterol levels. That means between the two, the input is the age and the output is the cholesterol. Age is explanatory, cholesterol is the response. Hope that squares away the concept of variable, explanatory variable, and response variable. we're ready to talk about what makes an experiment. An experiment is a study in which the researcher is intentionally introducing or withholding some treatment in trying to affect the output. That means the variable. Or if the study has a distinction between explanatory variable and response variable, then it means the response variable. That's the definition. Let's take a look at an example. A doctor wants to know if antibiotic speeds up recovery from the cold. She got a bunch of cold patients, so she gives some of them an antibiotic and others a placebo, meaning something that looks like an antibiotic, but it isn't. It doesn't do anything. It's like sugar pills. And she measures how long it takes them to get better from the cold. What's the population of interest? The cold patients or the population of interest? What are the variables? There are two variables here. Number one is what did the doctor give them, antibiotic or placebo? And number two, how long did it take them to get better? Now, the question is, did the doctor intentionally introduce or withhold something to try to affect the output here? Meaning the response variable? Press pause and try to answer before moving on. Yes, she did. The response variable here is the time to recovery. And the doctor intentionally tried to affect the time to recovery by giving some patients an antibiotic and withhold that antibiotic from some other patients, or you can also think of it as giving placebo to the other patients. That makes it a treatment. The treatment is what the doctor gave, either antibiotic or placebo. Since a treatment exists, this is an experiment. This example illustrates a very common situation, and that is, in an experiment, it's very common that the researcher manipulates the input variable, the explanatory variable, to try to affect the response variable. The treatment is the manipulation of the input of the explanatory. Now, a quick note about the ethics of this. When the doctor gives the placebo, that means the doctor is not treating the patient. Patients come to doctors, they expect the doctor to take care of them. And instead, a doctor gave them a sugar pill. Is that fair to these patients? Experiments often entail ethical issues. Think about other experiments that you've heard of or read about or participated in. You can see that most experiments, especially human experiments, involve important issues of ethics. So I'm just mentioning it here. I'm not going into it in this video, but I want you to be aware of it. Let's go back to distinguishing between observational study and experiment. Example 5. A health researcher selects a group of 200 random adults and separate them into two groups by age. One group is 40 or older, and the other group is under 40. She then compares the percent of people who smoke in each group. What do you think she's trying to achieve here? Press pause and think about it. What she is trying to do is to see if age affects smoking, right? The older people versus the younger people. What's the population of interest? American adults are the population of interest. What are the variables? Age category, 40 or older versus under 40, is one variable, and that is the explanatory variable. And the second variable is smoking category, smoking versus not smoking. And that is the output or the response variable. All right, now, is there treatment? Did the researcher try to do anything to affect the response variable? No, she didn't. There was no treatment. She just got a bunch of people and asked them their age and asked them, do you smoke? Right? No treatment here. Therefore, this is not an experiment. Well, if it's not an experiment, then what is it? Here comes our next definition. An observational study is a study that's not an experiment. You look at something, if there's treatment, it's an experiment. No treatment, observational study. Let's look at another example. An economist collects data on net worth of people who went to trade school to become mechanics compared to people who went to college to become mechanical engineers. What is the economist trying to achieve? Press pause and see if you can figure it out. In this study, it seems like the economist is trying to figure out what's better financially, right? Becoming a mechanic or a mechanical engineer. Press pause and try to figure out the population of interest and the variables in this study. The population of interest are the people that this economist wants to draw a conclusion about. So they are the mechanics and the mechanical engineers. And there are two variables. One variable is their net worth, but the second variable is who they are. Are they trade school mechanics or are they mechanical engineers from colleges? The economist needs to observe and keep track of both of these variables. Now, is this an experiment or an observational study? Is there treatment? Press pause and try to answer. No treatment. The economist is just observing the people, asking them, are you a mechanic or are you a mechanical engineer? What's your net worth? The economist is not manipulating or changing or introducing or withholding anything. No treatment, not an experiment. This is an observational study. All right, are we good? Now, you may ask, why bother? I mean, research is research, right? Why bother distinguishing them? The answer is because, generally speaking, an observational study can only show that variable X is related to variable Y, or not. It cannot prove that X causes Y. In order to show that X causes Y, you need an experiment, a well-designed experiment. That's why we need to pay attention to whether something is an experiment or an observational study. If you're doing your own research and you're trying to prove something causes something else, you need to do an experiment. The word for X causes Y is causation. If you're not doing your own research, but you're reading someone else's research, you want to make sure they don't claim what they have not shown. If they only do an observational study, they can't prove that X causes Y. And you shouldn't think that X causes Y either. The economist, for example, if the economist found a difference in net worth, the economist cannot conclude that the training and job of mechanics versus mechanical engineers causes any difference in net worth. No. The most they can do is say that there seems to be a relationship here. Yeah? Right? Are we good? Here's a summary. To distinguish between experiment and observational study, do this. 1. Determine the population of interest. Step 1 is not absolutely necessary, but it really helps you figure out step 2, which is find the variables, meaning the attribute or characteristic of the population we're studying. If appropriate, find the explanatory versus response variables. Step 3. Is the researcher changing something trying to affect a variable, or specifically a response variable? Or sometimes are they changing an explanatory variable trying to affect a response variable? If yes, it's an experiment. If no, it's an observational study. That's it. Hope it helps. Like, share, and subscribe for more contents. Any questions or comments, put it in the comments section below. Thanks for watching. Bye.